Graph. Graph is a set of objects which are called vertices. V along with pairwise connections called edges. Types of graphs. Directed graph, undirected graph, and mixed graph. So if the vertices before vertices are directed, really connected, so there is the edges have an origin and a destination. Origin, destination, but these are connected, so this is directed graph. In undirected graph, there is no directed edge, simple edge. There is a mixed graph. Mixed graph is a combination of directed graph and undirected graph. Mixed graph. Now let's see some terminology. Origin and destination. So suppose this is a vertex V1, V2. This is an edge. This is called origin, this is called destination. Because V1 then V2. Adjacent. Adjacent. Here V1 and V2 are adjacent. V1 and V2 are adjacent to each other. In degree, out degree. Here out degree of V1, out degree of V1 equal 1 because 1s comes out, and in degree of V1 equal 0 because no edge flows in. For V2 out degree of V2 equal 0, in degree of V2 equal 1. Parallel edge. V1 and V2, if this is an edge, this is another edge, both are parallel, It doesn't mean they are geometric. Suppose this is another. The three edges are parallel. Self loop. Again, parallel edge. Yeah. Parallel E parallel E D G E edges. Self loop. This is V1. V1 flows back to itself. So we see a self loop. Okay, so V1 goes to V1. Simple graph. It has two properties. One, no self loop. Number two, no parallel edges. Suppose this, simple graph. Path. Suppose this is a graph. So we go from here to here, and again here, here. So suppose this is A, B, C, D, E. You see, is this a path? Just a sequence of edges where previous point connects to previous edges, destination bar or next vertices. Just we say this is a path. So A, B, C, D, E is a path from A to E. There can be other paths like E, C, F. This is another path, or A, B, C is another path. Cycle. A cycle is a path. Cycle is a path that starts and ends at the same vertex, like A, B, C, D, E. Okay. We go A, then B, then C, then D. Okay. Till now, this is a path. Okay. Now, again goes to A. So A returns back to A, and this path is called a cycle because the path returns to the primary source. Okay, now connected graph. For any graph is connected if, suppose this is a graph A, B, C, D. A, B, C, D. Okay. So this is D, this is C. From A, there is no route to D. Okay. From B, we cannot go to D. So this graph is not connected. To be a connected graph, there must be a path between every vertex, each other. Like pick up any two vertex, there must be a path. So A to C is a path, but A to D, there is no path. This is not connected graph. But if I connect C to D, now it is a connected graph. Okay. Now strongly connected graph. Strongly connected graph. Strongly connected graphs are applicable for directed graphs only. If I pick any two vertex, I can reach one vertex to another and another to one, each other, reciprocal relation. Like you can see I can go to C, then D. Yes, but from there I cannot reach to A. So it is not a strongly connected graph. To become a strongly connected graph, how can I make it a strongly connected graph? From D, I can connect it to A. Okay. Now I can go to D, I can return to, from D I can return to A. Now I can go to C, but from C I can return to A. So from B I can create another edge, C, A. Okay. Likewise, D to C, I can go to C to D. Can I go to C to D? Yes. I can go to D to A to C. Okay, and go to C. Okay, B to C, any path? B to A to C, yes. C to B, yes. C to B, yes. B to A, yes. B to C, yes. B to A to C to D. So this is a strongly connected graph. Subgraph. Suppose A subgraph A, B, C, D, E. H, H, H. I will just randomly create any graph. Okay. What can I do? Create a graph. Okay. Now call it E1, E2, E3, E4, E5. Okay. So see. Now the vertex are A, B, C, D, E. Edges E1 to E5, E1, E2, E3, E4, E5. Okay, this is vertex. Okay, this is edges. Okay. Now to make a subgraph H. Make a subgraph H. We pick some vertexes like A, D, A, D. Okay, some edges randomly. Just choose E2, E4. Okay, E2, E4. Okay. Let's see how it can be subgraph. Okay. So A to D, we take A and D. So we erase B, C, and E. Now E2, E4. E2 and E4, okay, but E2 has no connection. Let's remove it. E4 has no connection with A. Let's also remove it. E1, no connection. E1 is not part of chosen graph. Okay. So just remove other things. Now A and D is subgraph, spanning subgraph. Okay. If a subgraph contains all vertices of original graph, then is a spanning subgraph. Spanning subgraph. Okay. Connected components. The maximal connected subgraph. Connected components. Yes. Connected components. Suppose I have a graph here. Okay. This. Okay. We see this just. So here we see this is a larger connected. Okay. This is a connected graph. This is another connected graph. But subgraph. Okay. We see here it is the largest one. It is not the largest one. So we can say this subgraph is the connected components. Okay. Forest. Forest is a graph with no cycles. A graph without cycles. C-Y-C-L-E-S. Okay, like any graph. They may be connected, may not be connected. A graph doesn't necessarily have to be connected. So, like this is a graph. This is a graph. You see, there are cycles, so they are not forest. How to make it forest? Let's remove the cycles. Okay. We see no cycles. Okay, remove it. Now this is the whole graph is a forest. Tree is a forest that is connected. So a tree is a connected graph but without cycles. So tree is a connected graph with no cycles. So it must be connected. Okay, connected, but there should not be any cycles. If it returns to it, then it is not a tree, so we remove it, and this is a tree. Okay, and it is okay, but we cannot connect this to that because that will create a cycle. Spanning tree. Okay, let's create a spanning tree. Spanning tree is a connected graph, spanning subgraph, that is a tree. So how to create a spanning tree? Like this is a graph. Now how to create spanning tree? We just take the vertices. Okay, and only we can keep only the necessary edges without any cycles. So remove it. Remove it. Have we connected all? Yes, but there is cycle. Remove it. You see, every vertex is connected. So this is a spanning tree.